my mentor tutor. I hope you stay safe, and you remember we started with acid and our target acid part 1, but this morning we'll be talking about acid part 2. And where am I going to start from? I'm going to start from this particular place. I said water can act as an acid and also as a base. Can act as an acid and also as a base. Therefore, water is what? An aphothermic substance. And what do I mean by aphothermic substance? Talking about water can behave as an acid and also as a base. One molecule of water transfers a proton to another molecule, and that results in the production of hydronium ion and hydroxide ion. How does it happen? Now, when you look at this particular one, this one molecule of water, this another one molecule of water. What happened? The proton from this one molecule of water is being transferred to this particular one molecule of water. Then how? When you look at the proton, this hydrogen plus, that's an empty what? Empty orbitals, and this molecule has a lone pair of electrons. The lone pair of electrons will be donated to this particular what? To this particular proton from this particular molecule of water. Because it's transferring its what? Proton to this particular molecule, this one become an acid. Now I've told you that an acid is what? An acid is a proton what? Donor, while a base, it become a base, is a proton acceptor. A base is a what? A proton acceptor. It's accepting what? A proton from this molecule of water. And when it accepts proton from this particular molecule of water, what happens? It forms what we call hydronium ion, meaning the hydrogen becomes 3, yeah. And because it has what? Accepts this particular proton, it carries negative charge, while this one becomes hydroxide ion. Why? Because it has lost its proton to this particular what? A molecule of water. Because of this, we say acid can be what? We say acid is an aphothermic substance, meaning it can behave as an acid and it can equally behave as a base. Good. Now, activities for the students. Who are the students? You are there for testing for acid in fruits. Materials are, try to get them. We have 4 lemons, 4 penny copper wires, 4 zinc galvanized nails, a set of alligator clips to hold them together, or a flexible copper wire. Get it from fuel station, and lead bulb and knife. So what do we expect you to do? You can equally watch it on our YouTube page. This lemon for lemon. Then you put zinc and penny. You put zinc and penny. You put zinc and penny. You put what? Zinc and what? Penny. Said and copper, zinc and copper, zinc and copper. Then you have zinc and what? Copper. Then the connection will be like this. You connect this one to this, you connect this one to this, then you connect this one to this, then yeah, connect this one to your bulb and connect it to this particular. Therefore, in this particular case, what happened? The bulb will be light up. Make sure you do the activities or you watch it on our YouTube page. Now, this is the chemistry of what happened in that particular solution. The zinc nails and the copper pennies are in series with the fruit solution, which has already been mixed with water in order to release the ions present in it. The 2 electrodes allow the ions to move in and out of the solution, thereby creating a potential difference between them, which can be seen using a voltmeter. The current flows out of the penny and enter the nail and enter the acid solution to complete the circuit. Finally, connect the bulb to the both sides of the wire. As the electric passes through the bulb, it lights up the bulb. Therefore, light up the bulb. And that's what actually happened when you connect the initial experiment I showed you. And we're going to be talking about concentrated and the what? Diluted acids. Therefore, what is a concentrated acid? A concentrated acid is an acid with little or no water. They are corrosive because of the relatively large amount of acid content in them. And why? The diluted acid is an acid with a large amount of water added to it, and such solution can easily be used for bench reagents. Meaning most of the reagents we see in the lab, they are diluted so that it will not harm you. Now the question here is outline how a 250 centimeter cube of 0.100 mole per den cube HCl could be prepared from 100 centimeter cube of 2.00 mole per den cube store. Solution. This one is only telling us that the stock solution has what is 100 centimeter cube in contents and the concentration is 2.00 mole per dn cube. Now, if you remember your dilution factor, this is the dilution law that says C1V1 equals to C2V2. C1 is the initial concentration of the concentrated solution. V1 is the initial concentration of the initial volume of the concentrated solution, while the C2 is the final concentration of the diluted solution, while the V2 is the final volume of the diluted solution. Now, to determine the volume of acid to be pipetted or measured, you can use C1V1 of concentrated solution equals to V2 of diluted solution. Then you make V1 the subject of the formula. While we're doing this, we wanted to know the content we are going to remove from 100 centimeter cube of stock solution. Then when you do that, you have 12.50 centimeter cube. Now the method is you pipette or you measure 12.50 centimeter cube of stock solution into a 250 centimeter cube volumetric flask containing some distilled water. Shake and add more distilled water until the mark is reached. Now you'll be wondering, this is the concentrated solution. You have to be very careful when you are measuring it using your volumetric, when you are measuring it and pointing to a volumetric flask. Now we'll talk about strong acid and a weak acid. Now, what is strong acid? What is weak acid? Strong acid is an acid which ionizes completely in water to give a higher number of hydrogen ions in an aqueous solution. Look at this example. It's giving higher numbers of hydrogen ions in an aqueous solution. While weak acid is an acid that ionizes partially in water. Is a weak acid. It's ionized partially in water to give what? Hydrogen ion in solution as well, but not as high as that of the strong acid. In terms of conductivity, then what happened? The strong acid has a higher conductivity because the numbers of hydrogen ion outnumbered the weak acid. The catalytic property of an acid in solution are due to the presence of this hydrogen ion or proton that is present in the solution. For example, when dry hydrogen chloride gas is dissolved in water and methylbenzene, what happens? In water, it forms hydrogen ion and behaves like a typical acid, while in methylbenzene does not form hydrogen ion and does not show any acidic properties. Thus, an acid has at least one ionizable hydrogen atom in its molecule. What are we talking about here? When you have this particular one here, I have HCl. Then by the time you put it in water, it will give hydrogen plus and plus what? Cl minus. This is showing you what a typical acid substance. But in methylbenzene here, we have a methylbenzene. And you have what? Methylbenzene. In H2O. what happened here? Because methyl benzene does not have what? Hydrogen ion. Thus, it cannot show any what? Acidic property. This cannot show any what? Acidic property because there is no presence of what? Called hydrogen ion. That's what actually happened. Meanwhile, when you have this in water, this is what is going to form, and that is a typical what? Acid substance. Now, before I come down to this, I need to show you this the strength of an acid. How can we determine strength of an acid? Yes, the strength of an acid is basically measured by the concentration of hydrogen ions you have in the what? Solution. Therefore, in order to measure the strength, you have to determine what we call a Ka. And what is Ka? Ka is acid dissociation what? Constant. And this is what we use to measure the strength of an acid. Now, when you look at it before dissociation, we have a strong acid and we have a weak acid. Before dissociation, say after dissociation, the numbers of what hydrogen ion present in the solution is high. Meanwhile, for the weak acid, before dissociation, then after dissociation, what happened? The concentration of what the hydrogen ion present has suddenly be reduced drastically, meaning that weak acid will have a what? A little strength when compared to what strong acid. Meanwhile, strong acid will have a what? Higher strength. Then when you have different acid, even you have a strong acid present, how can we determine which one is stronger in strength than the other? Yeah, in order to do that, have to come back here. When you have this an acid and you dissolve it in water, it forms hydronium ion and they conjugate what? Base. For simplicity, what happened? The water here take up, we are using what? H, we are using hydronium ion where it is equivalent to what? A proton to equivalent to what? Proton. Therefore, when you have this particular solution, this is what you are going to find. Then we can determine, according to what law of mass action, you can determine the acid dissociation what? Equilibrium. When you call it the Ka becomes hydrogen plus concentration plus what? A minus to give you the concentration of the what? Reactant. This is the concentration of the product over the concentration of the what? Reactant. You discover that the water is not involved here because water is what we're using to dissolve the substance. We've already told you that acid is a what? Any substance that when dissolving water, you have to dissolve them in water, produce hydrogen ion as only positive ion. Therefore, in that case, Ka is called the acid dissociation constant. In dilute solution of the what? Of the acid, we note that the concentration of water, liquid water, remains essentially constant. We are not adding water to it because it is essentially what? Constant. Therefore, the term included in the what? In this equilibrium expression, the strength of an acid is defined at the what? Concentration of what? Hydrogen what? Plus. Concentration of hydrogen plus ion in its aqueous solution at a given temperature, because temperature can be what? A critical factor that can affect the what? The solution. Good. Then we can now talk about this. Now look at this particular table. When you look at this particular table, it's mentioning what? And this particular one is showing the strength of all this particular, it's showing the strength of all this particular what? Acid. And then when you look at it, what is going on here? See, the increment is coming from down to what? Up. The one now, these are monoprotic acid, meaning having just hydrogen plus ion in their solution. Having one hydrogen ion in their solution, then this is the strongest because the hydrogen ion concentration here is higher than when you have it in here, then when you have it here, when you have it in diazo chloride 1, and when you have it in this particular chlorine, ethanoic acid, then well what? When you have it in hydrogen fluoride, when you have it in hydrogen fluoride, compare with what? HNO3, then hydrogen fluoride will be stronger than HNO3, then all this down and weak acid then it goes up towards C3COH. Good. This is the table for what? for their what we call acid dissociation constant, which we use to determine the strength of this particular acid. Then when you look at this particular one now, we're talking about the effect of weak acid. What we involve in, it's indirectly or directly affects our environment. Then when you look at this, then when you release gas to the environment and the gas released to the environment is not taken care of or not properly managed, this is what is going to result to. And when you look at this particular environment, you discover that the plants are dry up. Why? Because of the effect of acid on them. Therefore, when you have triazosulfate acid, the triazosulfate acid is found in the acid rain. The triazosulfate acid is found in the acid rain, and this particular thing is as a result of our activities. And it is a weak acid, which we know, but what happens? It further oxidizes to triazosulfate acid, which is a strong acid, and this damage our environment quite very bad. Therefore, we have to talk here. I'm talking about peace education. We have to advocate for good practice so that our environment can be safe. Now we talk about the properties of an acid. And when we're talking about the properties of an acid, let's talk about the physical, the one we can use all our senses to feel, to touch, to taste, all that. Then the first one is dilute acid. They have what we call a sour taste, and then they also turn blue litmus paper to red. Anything that turns blue litmus paper to red, and what is blue litmus paper? They are indicators that we use to determine whether a solution is acidic or base. Now we have concentrated acid. I've told you that concentrated acid are very, very corrosive. For example, HNO3. And you have to remember that you don't add water directly to acid, but you add acid to water. What happens? Because when you have acid and you are pouring water to heat, you have water here, you are pouring water to heat. The heat here is low, while the heat here is high. And you remember, the movement will flow from what? Should have been in this direction, from high to low. By the time you are moving from low to high, what happens? It splashes. Because there's no how a low solution can increase the high concentration. The flow of heat will move from higher to lower. Therefore, in this particular case, when you try to add water to this, what are you trying to do? You are trying to making a solution to splash. And in that case, you have to be very, very careful in order to avoid splashing on your body. Therefore, you add acid. You can make this low heat content to become high by gradually increasing the heat by applying higher heat to them. Therefore, in this particular case, you should add acid to water in order to avoid splashing on your body. And somebody will ask me, what kind of reaction when you add water to acid? That kind of reaction is exo. But when you're adding acid to water, that is endo. Because gradually it will be absorbing the heat and increasing in the temperature of that particular content. So you have to get that to our brain as we learn chemistry. Good. Now let's talk about chemical property of an acid. Basically, when we're talking about chemical property of an acid, we're talking about a reaction, something that involves reaction. And basically, I'll be talking about three of them here. I have the reaction of acid with metals, I have reaction with base, I have reaction with triazocarbonate for ion. In this particular case, reaction of acid with metals. Acid reacts with some metals like zinc, iron, magnesium, etc. to give hydrogen gas. Such reaction is due to the displacement of the acid ion in the acid by the metal, except that of HNO3. Why? Because HNO3, when hydrogen ion is being displaced from hydrogen gas, the hydrogen gas further oxidize to water immediately. Therefore, in this particular case, we are picking HNO3 as an exceptional substance that we should not be used when reacting what acid with metals. Now this is the table. This particular table is the activity series of metal in aqueous solution. It's showing here the reactivities of all these metals. Lithium is more reactive than what? Potassium. Potassium is more reactive than what? And barium. And what happened? Any of this metal that is above what? Hydrogen can display hydrogen ion in acid to produce hydrogen gas. Any of them that is what? Above it. And this one is more reactive. It display the rate at which you will display hydrogen ion from acid will be very, very high, probably because of the what? Atomic size. And anyone below hydrogen might find it so hard to display what? Hydrogen ion from an acid like copper, silver, mercury, platinum, and gold. They find it so hard to display what? Hydrogen ion from what? From an acid. And that is the implication of this particular table. You need to understand it. Now let's quickly talk about the demonstration of the what? Reaction of acid with magnesium. Now we're using magnesium as a metal and we're using hydrochloric acid. Now what happened? Look at this. The hydrochloric acid, you have hydrogen plus and Cl minus, and this is the solution of what? HCl. Now when you are putting magnesium into the solution, what happened? When you are putting magnesium into the solution, what happened? Magnesium solid is being oxidized by losing what? Electron. And what happened? The hydrogen ion in what? In the acid is what? Reduced by gaining what? By gaining electron to turn to what? Gas, and the other one forming what? Magnesium chloride. In this particular case, when you have what we're saying here, you have HCl plus Mg to give H gas plus MgCl2. The oxidation number of this one here is -1. The chlorine is 0. So the chlorine is -1 as well. -1 as well. This one is 0. Oxidation of any substance in a free state is always 0. What happened to this one? This one has become 0. Then what happened to magnesium has become +2. Therefore, we pick it from here to here, then from here to what? Here. Increase in what? Increase in oxidation number. That one is called oxidation. Therefore, what happened? And you see it has lost 2 electrons. That's why I say magnesium is oxidized by losing what? Electrons. It has lost 2 electrons. Why? Look at this particular one. From -1 to 0, what has happened? What has happened to this particular hydrogen? What has happened to this particular hydrogen? You are moving like this. Look at the way you are moving so that you can understand it better. This one is what? +1. Therefore, you are going from +1 to what? 0. There's decrease in oxidation number is called what? Reduction. Decrease in oxidation number is called what? Reduction. What happened? Hydrogen ion has been what? Reduced by gaining what? Electrons, because 0 in this case is better than 1. When it is +1, it means you are losing. When 0, it means you are on your stable state. And when it is minus, it means you are gaining more. Therefore, what has happened here? It has gained what? Electron to become 0. Therefore, in that case, we say hydrogen ion has been reduced by gaining what? Electrons. And that's what actually happened here. We say the reaction of magnesium metal with hydrochloric acid. The metal is readily what? Oxidized by the acid, producing what we call hydrogen gas and what? Magnesium chloride salt. Good. Now let's go to chemical property of an acid again. Here we're talking about a reaction of acid with base. That is the second one. The reaction of what? Acid with what? Base. Acids react with insoluble base and alkaline, for example, calcium oxide, potassium hydroxide, to form salt and water only. The reaction is known as what? Neutralization reaction. We're talking about reaction of acid with what? Base. This can be either soluble or an alkaline solution, the one that is soluble, to form what we call salt and water. Now, adding just a few drops of water, hydrochloric acid, will not be sufficient to dissolve all the magnesium hydroxide. Why not? Why not? Can we illustrate this? Look at this particular one. This magnesium hydroxide. Look at this magnesium hydroxide. This magnesium hydroxide, remember, T is a base, insoluble base. It is a base. What is now going to happen? We need to add acid to it. As we're adding acid to it, we need to add enough acid that will be able to dissolve all the magnesium hydroxide in this particular and begin. Now what is happening here? We have to add enough acid to it, and in that process what happens? It becomes See, all the acid has been dissolved. In such reaction, in this particular reaction, this is a reaction we call a neutralization reaction. Let's quickly see what happened here. We have magnesium hydroxide. Magnesium hydroxide with HCl. See what is going on. It's forming what we call magnesium chloride, salt, and H2O. Now, this illustration shows the neutralization reaction. We see you've already neutralized all the base between the magnesium hydroxide and the hydrochloric acid. The milk of magnesia is a suspension of water suspension of water, that is insoluble magnesium hydroxide solid in water. When sufficient hydrochloric acid is added, that's very key. Hydrochloric acid is added. A reaction ensure that leads to this reaction ensure that aqueous solution containing magnesium ion and the chloride ions are formed. Now say what is actually going on. Now I've already told you we have here, this one will split into 2 plus, then OH minus, then 2 of this one, then plus H plus and Cl minus. Then look at this, this will go to this and this will go to this, to form what we call this magnesium chloride plus H2O. Then we balance it, I put here H2O. What has happened? This kind of reaction is what we call a neutralization reaction, because we're using the acid to dissolve the base. Wow. Okay, now the chemical property of acid. The next one we're going to talk about here is a reaction with triazocarbonate 4 ions. You need to know that acids react with triazocarbonate 4 ion to liberate what we call carbon 4 oxide gas, and this just the illustration. You see the acid we have triazocarbonate 4 salt ion to give us salt, water, and CO2 gas. And the example we're picking here, we're picking H2SO4, 2 molecules of this, and we have SO4 2 minus. Then this is salt. This is salt from triazocarbonate 4 ion. Then CO3 2 minus. Then what happened? This will react, and this will react. Then to form K2, which is the salt we're talking about, K2SO4, then plus what? H2CO3. This is a weak acid, and this weak acid is an unstable what? Acid that will further what? Split into water and what? CO2. Therefore, in that case, see when the acid what happened when the acid reacts with carbonic 4 ions, they are going to give carbon dioxide. And when you look at it, we say carbonic 4 ion is unstable. If present in solution in sufficient concentration, what happens? It decomposes into H2 and CO2, which escape from the solution as a gas, as I have demonstrated here. Therefore, when you have the weak acid, you break down into this, and the overall reaction summarized below. You can when you use sodium hydrogen carbonate with HCl, this also results in HCl. What happens from sodium chloride, water, and CO2, which is given off as what? As a gas. And this is the ionic equation for it. Both sodium hydrogen carbonate and sodium carbonate are used as a neutralizer in acid spill. Either salt is added until the freezing caused by CO2 formation stops. Sometimes the sodium bicarbonate is used as an antacid to soothing an upset stomach. In that case, the HCO3 reacts with what? Stomach acid to form CO2. I've told you that the stomach too has what? Acid. Because by the time you use sodium hydrogen carbonate, it's going to have the HCO3 minus, which will further react with the what? Proton in the stomach, because the stomach too has what? Acid. And when they react together, what happens? See, the stomach has what? A proton in the stomach reacting with this particular one from what? Sodium hydrogen carbonate inside the stomach, and what happened? They form a weak what? Acid. And what happened to this weak acid is an unstable acid that will further give water plus CO2. And this CO2, what happened to the CO2? CO2 will what? Release from our body, and that's what actually happened. Therefore, we're going to stop there for today. Then the next class will start from what? Basicity of an acid. I hope you enjoy it. If you do, please, I want you to subscribe for more videos. Thank you for watching.